Okay, today we are going to discuss the paper called Self-Discovery, Large Language Models, Self-Composed Reasoning Structures. And this paper is from Google Deepmind and from the fellow researchers in University of California. So as you can see, it was published in February 2024, and I'm trying to do some of the quick review of the paper. So let's jump to the contents. So we'll be talking briefly on some of the backgrounds that you need to know, and I'll introduce the paper. We will talk about the methods, experiments, and finally conclude and try to see some limitations in this paper. So okay, I'll skip this Korean summary. And the background. First of all, we need to understand what is um, direct prompting, right? So what means direct prompting? It just means, okay, let's say this is our LM models, right? Okay. And what we are doing is you as a user, what you do is you send some of the questionnaires to this language model and expect some of the output, okay? Okay, anyways, yeah, you as a user, you ask some questions to this language model. Just think of it as, let's say, GPT, okay, and you get the output. So in this case, what you are doing is you are not giving any examples or you are not giving any you know, some of the reasoning. So in this case, what we are doing is we are just directly asking the questions, right? So that's direct prompting. Okay, and then another is RM. RM means a reasoning module. So reasoning modules means there are a lot of reasoning techniques. So for example, we can say like critical thinking and think step by steps. So these are all of the reasoning techniques or reasoning modules that we're going to see in this paper. Another background knowledge you need to have is the LLM's reasoning. So LLM means large language models. The ability of these large language models to break down complex problems and try to come up with the solution is their reasoning. Okay, we call them as reasoning. So solving problems step by steps. In this LLM reasoning, there are some of the techniques that the researcher or the scientists have found out. That is, one is chain of thought. Chain of thought means so you ask the LM models to um, first of all, for a given complex problem, so it has to think of it as the blocks. Okay, first I do this, and then I'll do this, and then I'll do so this kind of thing. Okay, so it is trying to get the solution of the complex problem, but with some of these steps. So and one step linked to another, another step linked to another. So it's kind of like chain, right? So that is what is chain of thought. And plan and solve means we first of all what we do is we plan everything. Okay, we just lead number one, we do this, number two, we do this. Okay, so we plan them, and then based on this plan we execute the code, right? Okay, so based on these plans what we do is we execute the code. So that is planning reasoning. Okay, finally the self-discovery, which is this paper. And this paper says instead of planning and reasoning, I mean instead of doing yeah, planning and reasoning, how what about we first of all derive all the reasoning models. Okay, so first of all get all the reasoning models. So there are critical thinking, step by step, these all kind of reasoning models. And based on that, what we do is we select what is important for this particular task. Let's say there are only two reasoning model which we find are important. And in third step, what we do is we kind of sort them. Okay, so first of all, this reasoning model is good, and then this is good. Okay, we structure them, and finally we come up with the answer. So this is the final answers. Okay, yeah. This is the self-discovery. And so in this paper, they have discussed this kind of technique in here. So another basic you need to know is chain of thought self-consistency. So COT, self-consistency. That means generating multiple COT. That means generating multiple chain of thoughts or multiple steps, right? And then choosing which one would be the most relevant one. That is self consistency, okay, in COT. Another is majority voting of each RM. RM means reasoning model. So in this paper, we'll talk about the reasoning models again, like in later slides. But what they do is they choose the most common answer from all these reasoning models. What is the most common answer? For example, if we say 3 plus 3 equals to how many as a question, and there are around 39 reasoning models in this paper, and most of them say 3 plus 3 is equal to 6, then that means we choose that as a common answer. So best of each RM means for each reasoning model, let's say reasoning model 1, reasoning model 2, so up to 39. So for each reasoning model, we select the top performing reasoning model for those kind of answers. For example, in addition, like in 3 plus 3 problem, okay, what we do is we select the reasoning model 1, okay, and then we check its performance, okay, and if this reasoning model is performing well, then what we do is we select this reasoning model as um, the reasoning model for the further steps, okay. So that's the best of each RM, selecting the top performing reasoning model based on the answers they give. In this part, what we need to know is we need to have the prior ground truth. That being said, we need to know 3 plus 3 equals to 6. So we need to have the 6 level prior to the testing this uh, task, okay. Um, so this is again, I already talked about this type of prompting. So in the direct answers, where is here? So in the direct answer, you just question asking questions, right? And let's say this is the LM model. So it gets the tags and it has to come up with the answer. So that's direct answering. And whereas in COT, COT chain of thought, what we do is we give COT chain of thought, for example, this kind of COT chain of thoughts. And then we ask the LM models to come up with reasoning. Okay, this is LM model. So yeah, and we get the reasoning from there. And from that reasoning, what we want to expect is we want to get the answers. Okay. That's the COT. And finally, the self-discovery reasoning structures. That means their technique is to first of all find out um, the tasks with okay. So given the tasks, what they want to do is, so this is LM models. Okay. So not here. Okay. So this is the tasks, and what they want to do is from the LM model. Okay, they want to derive all the specific reasoning structure um, and structure them in reasoning way and get the answer. So what do I mean by this? I'll explain them in detail in another slide. So just basically just know that what they are doing is they are giving additional steps. For example, not just giving tasks and some reasoning structure, they are also giving task specific reasoning structure to get the answer. So in self-discovery, as I discussed, they have given additional step, that is the adaptation steps, or not just implementation. Okay, so what they do is first of all they select the reasoning that are available. In our case, there are 39 reasoning, and from those 39, they select first of all how many they need. Based on those selection, they adapt the particular task with that reasoning, and finally use that to implement and get the answers. Okay. So um, it's just the explanation. So pick the most helpful reasoning model, customize it, and then create the step-by-step plan to uh, get the answer. So from there, what we do is we can dissect it and get some of the so for example in here, as you can see, so selection is there are like 39 reasoning models, right? There are 39 reasoning models, and from there, for example, the tax is provided for the LM models, and from those above 39 reasoning LMs, sorry, reasoning module, the tax is customized, or let's say for the tags, these reasoning modules are selected from the 39 modules, and so and then pass on to the adaptation adapt second step, that is adapt, right? So you can see select several modules that are crucial for solving the tasks above. And in adapt module, what they do is given the selected reasoning model, for those tasks, they want to adapt each reasoning modules to get the solvable tasks or solvable answers. Okay, adapt each reasoning model description to better solve the tasks, right? And finally, in the implementation, what they do is, oh, okay, we have what we have. We have the paired uh, implementation step. That means all the reasoning model, right? And we have their description and we got the steps plan. Now we want to implement the structure for the above given reasoning model to get the step-by-step answers to get the final output. So that's what they are doing in the implementation steps. Okay. So as you can see, it is like there is a task, and this whole big box is the self-discovery, and there are 1, 2, 3 steps they are doing, and from that what they do is they get the reasoning structure. Okay, not the final step but the reasoning structure. So that is the whole technique they are doing in this self-discovery. So what exactly they are doing in the first stage, that means in selection stage. So we already have LLM model, that means let's say in our case GPT. Okay, GPT. And from this model and from this tags, okay, we get um, some of the atomic reasoning. Oh, sorry, we also give the atomic reasoning model. Okay, and in the three-step self-discovery, we pass that into three-step self-discovery and get the reasoning structure. So this is what we get. So these are the reasoning structure we are getting. Okay. So this is again the three steps, what they are doing in step-by-step way. So they are selecting, first of all, they are selecting this, um, here they are selecting, right? And they are adapting, they are implementing. So in selection steps, there are all the seed modules and they pass that into LM module and get the selection. First step is done. In second step, based on this selection, okay, the selection modules, what they do is they pass to the LM modules, and then based on this selection and based on the tasks, give me the step by step or structure steps. So this for example, if their selection is 1 comma 2, and in here maybe the LM models find out, okay, 2 comma 1 is the better flow to go to solve this task. Okay, so this is done in this part. And in third part, implementation part, what they do is the adapted module is passed to the this is passed to the LM models, and they get the structure with the um, given task specific problem. So here is the reasoning structure step by step. So the difference between this and this is this only sort the reasoning model. For example, first think critically, then do step by step. Okay, this is what they do in this part. And in this part, what they do is, okay, first critically think about the tasks of 3 plus 3, and then think step by step how you can solve 3 plus 3. So it becomes more case specific, and whereas this become more like the module, or let's say sorting of the modules. So that's what is happening in here. Okay. And okay, in stage two, uh, after they find the task, okay, so after they find out the reasoning structure, this one, okay, and then they have they already have the task instance. So they pass into the language model and they get the answers. They get what was it? Anyways, they get the answers. So that is happening in the stage two. Is like a simple clear cut structure. So nothing more in the this part. Okay. Okay. And in the method, what we want to discuss is we want to focus on um, the 39 reasoning model what they have passed here. Okay, so okay, in the method, what we want to look at is what are the 39 reasoning models. So there are a lot of reasoning models. For example, you can see so yeah, for example, you can see the first is how could I devise experiment to help solve that problem, or make a list of the ideas for solving this problem and apply them one by one to the problem to see if any progress can be made. So these all are the reasoning models. Okay, so and from these reasoning models, okay, I try to list all of them here. So from this reasoning model, what they are doing is taking these reasoning models and trying to solve the problem. Okay, so from that, what they got in the results, so we'll check that in experiment a little. First of all, they captured the result in for the three data sets. So one is BBH, big bench, BBS, another is T4D, another is math. So these are, sorry, consider tough or hard data set for LM models. So there are a lot of data sets to check the performance of the LM models, but this data set is considered. So these are the data set that consider tough. Okay, so these are their selection. Anyways, so that is big bench hard. I think the BBS means. I have to check it anyways. And their performance is significantly better, right? So if you see all the three techniques, for example, they use PaLM and GPT-4. Yeah, so PaLM and GPT. So PaLM is from the Google, and then GPT-4 is from, the well, know what GPT is for from OpenAI. So compared to the GPT-4 models, PaLM model is doing not that better, but yeah, it's okay in this. Sorry, it is really low as compared to GPT-4. PaLM 2 is low, but as compared to all the other techniques of CO2, COT and PS means plan and solve, the self-discovery is doing better. You can see performance improvement in all these three dataset, and as well as for the another model, GPT-4 model, the performance improvement is also seen in all of these three models. And but if you look at the big bench, I don't know, BBH dataset, okay, BigBench-Hard, yeah, BigBench-Hard tasks. There are some tasks that this dataset was not able to do well. Okay, so for example, you can see these are the tasks. So especially in the multi-step arithmetic and penguins in a table, tracking softfold objects, wave of lies, and word sorting, they didn't do much better in those tasks. Okay, so as compared to COT, the self-discover was worse than COT. Okay, this is what we can see in this result. And so this again is the experimental result for showing how their method is performing. And if you can see in all of the tasks, they perform well. So performance improvement was seen in all of the tasks. And out of 99 module, the wrong model prediction. So in the cases of the wrong model prediction out of 99, right? So 70% is due to intermediate math computation. So they say that so their math competitions like in the prompt reasoning that has uh, resulted almost 74% of the errors in the like intermediate step. So this is first step, this is last step, like the final answer. So in the intermediate step it has made the most mistake. So that's their uh, that is what they are explaining here. Okay, and that's is the another result. So they try to see in depth what are the some of the in-depth results. So what they do is they again BigBench-Hard dataset, they categorize it into different categories. For example, problem categories, so multilingual categories, arithmetic, algorithmic category, NLU, and old knowledge, and they found out their prompting was better in old knowledge. So you can see the average delta change in the old knowledge is higher than all the other technique, right? So it is higher. So that's their experiment. And I think, yeah, this is again, this technique is already incorporated in the library, or in the prompting technique or library. So it's a one of the um, important discovery in the prompting technique. Okay, there are a lot of techniques that they are introducing, so this is one of them. I would maybe not important, I would say. It's yeah, it's just basically the approach that works. So in conclusion, what they do is they propose the self-discover, which is a framework that enables these models to do their structured reasoning for these tasks. Another thing is they achieve around 32% better performance on these challenging tasks than as compared to other techniques like especially CO2 and direct prompting. And they outperform COT self-consistency by more than 20%. So, and then in the inference time, what we can see is they are like 10 to 40 times doing fewer inference than the CO2 self-consistency. Because so though it takes a lot of time for to complete all these steps, right? Because they have to select all these models and then yeah, add up to these models, right? Make a order or listing or structured listing, and then finally they have to make the final implementation, or make the reasoning structure based on the particular task. It takes like three prompting for that one, for selecting, for adapting, and for implementing, and then after that we have the reasoning structure, right? And for that task they don't need to do further inference through for the at least for to make a reasoning structure, and they can just use that to run the another task examples, okay, from that structure. So what are the limitations? Though they say that it is like 10 to 40 times fewer inference, but still we can see in the first stage they have to do like three um inference to LM models, right? Whereas in the COT or direct prompting, we can just directly prompt and don't have to bother further about that. um, Another is the performance is we can see the performance is lower in some of the tasks, for example multi-step algorithm and CO2. That's because they say that it's because of the intermediate error in while solving the math problem. So these are their main limitations, I think, and which also they have mentioned in the paper. Mm, but other than that, we cannot be sure. We don't know if this prompting technique is better in all the other dataset. Like maybe it's better in BBH and T4D and these three dataset that they talk right in this paper. I forget the third one. Anyways, so that's the limitations, and so that's about it for this paper. And feel free to do some comment if you have, and then maybe ask some questions. I'm up to that. And thank you for listening. And it's a good paper. I think you want to have a look on this if you want. And then they have not officially released the code, but some of the other fellow member have not there, but other people have tried to get this implement this one. So there are some paper yeah, there are some code in GitHub you can find with self-discovery if you search that in GitHub. Anyways, it was good to have your time, and thank you for listening.